Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our modern C++ series. In this lesson, we're going to continue looking through the standard template library, the STL, and looking at the list container data structure. Now, lists are sort of another useful data structure when we don't want to use vector. So we're going to compare and contrast them a little bit, but let's go ahead and look on CPP reference just to get a high-level idea of what a list is. So from CPP reference, let's go down to containers, zoom in a bit, and we're going to go ahead and look at list. Now, I've previously looked at array-based data structures, so the array itself, and vector. So make sure you check out those lessons if you haven't previously. But again, as we look through the different containers, you'll find out that, well, the standard template library has a lot of similar functionality. But list's underlying data structure is a little bit different. So let's go ahead and take a look at it. Now, the first thing to notice from the help page here is that random access is not supported in a list. And that's because we're working with, well, what's in the next sentence here, what's usually a doubly linked list here. So let's go ahead and draw this out. And again, just understand very briefly what the differences are between a list and something like a vector. So with a list data structure, we're usually thinking about nodes here. So for a list, we usually have some sort of node, and then we're able to connect those nodes with pointers. So that has certain implications about how we're able to access things. So compare that to a vector or an array, which is a statically sized vector, which we've learned about, which has all of our memory chunked together, and we can't resize it, but we get the advantage of being able to randomly access each of the indices here. Versus a list where we don't really have that notion because our pointers are really anywhere in memory here. Typically we think about this as a linear data structure, but from a memory perspective, we might be going sort of all over the place depending on how we've allocated or how our list is structured. So that's the fundamental difference. And list, as far as C++ is concerned, is usually implemented as it's stated as a doubly linked list. So that means we can traverse forwards or backwards. Now, of course, we have reverse iterators in vector as well, because, well, it becomes trivial to move backwards or forwards in a contiguous data structure. And later, we're going to talk about in this series forward lists, so make sure you subscribe so you don't miss that, so we'll understand what the difference is versus a plain old list. So this is the picture to roughly have in your mind. And again, from our last node, we should be able to get to our first node, and as well in the other direction. So it'll look something like this when we in typical implementations in the standard library. So when thinking about this data structure, just think about where I'm going to be doing my insertions. Again, if I'm going to be inserting into the front of this list, that's usually really fast. I'll give you a reminder of that, but we call that O of 1 or constant time insertion at the front or the back of our doubly connected linked list here. So that's the sort of advantage of a list here versus, again, if we have to insert something in the middle here, that could be a more costly operation because we'll have to traverse the list and find out the exact insertion point here. Now, sometimes we'll have to be a little bit careful when we talk about like insertion and the exact cost. So as long as I have, I should say, an iterator to this exact point where I want to insert at, then I can insert things in constant time. That's easy. Versus a vector, which we have to be a little bit careful about. If I wanted to insert or expand this data structure so that I would have more nodes here, I would effectively have to scoot everything to the right here and add in my new element, wherever that happens to be here. So some value here, let's just say it's a value 7. And that is costly. So insertions in, say, the middle of the vector, we have to pay the price for a doubly connected linked list, as long as I have the iterator to my position here. So I've, either kept track of it or I've just iterated through this list, I should be able to insert in constant time. And of course, if I do an insertion in the front or the back of the list, that should always be constant time. So we'll have some similar functions like pushback that we've learned about, for instance, but I'll also show you some things like insert and removal from linked list and so on. So really, you just have to think about what types of operations you're going to be using in these data structures. So if I have a linked data structure like the list, how often am I inserting? Do I need random access? Those are usually the types of questions that you're asking. And with a vector, again, you're usually thinking about, does locality matter if I have lots of contiguous elements, and how often might I need to rearrange these particular elements? So hope that gives you a little bit of an idea. A data structures course or algorithms course should cover these different things here. And if you'd like to learn more about that, let me know in the comments. But otherwise, let's go ahead and just take a brief look at list, and then we'll dive into some coding. So again, looking at the actual structure of a list here, again, we're going to create a list of a certain type, and we can sort of think of these as the individual nodes in that particular list. For the purpose of using the standard template library. Now, I will tell you there are sometimes differences with intrusive versus extrusive lists as to where the actual data is stored, but not something we have to really think about. We just want to think about the operations we're using here. And then, as always, we usually have, in many of these standard template library containers, an allocator that's defaulted to the sort of default allocator. But again, you could have control over this, especially if you're diving into more what would be C++, I believe, 17 style stuff, where you have a little bit more control over allocators. All right. So anyway, let's go ahead and look at some of the member functions here. Again, things that should start to look familiar, accessing the front and the back. We've got various iterators, so we'll take a look at those, and even some reverse iterators. We didn't take a look at those with vectors previously, but we'll take a look here. Capacity, size, some different modifiers. Again, there's pushback again. And there's a few special sort of operations here for merging with a list and so on. So we'll want to take a look at some of those. So without further ado, let's go ahead and just kind of run through some of these here and set up our project. And what I'm going to do is just include IO stream so we can do a little bit of output. And then I'll also include the list so that we can get started with using it. So let's just go ahead and start from our program here. And I'll go ahead and make this just a little bit bigger so you can see for now here our program. Let's just go ahead and create a list here. So again, this is a templated structure. We're just going to pick integers because they're kind of easy to work with for these examples here. And then we'll go ahead and create my list. And that's all really there is to it. And then we could use some of the things that we've learned about previously, like pushback. I'll push back 1. Let's just push back a few numbers here. Here we are. How about 4 numbers here? And let's make them different. Again, just something that's kind of useful when you're testing out. Now, so as I'm pushing each number back, I'm essentially appending to the end of the list here. So that is a constant time operation. Let's go ahead and give ourselves a little look at that as we visit these operations, because I want to show you what the complexity is here. So again, pushback, again, append to the end of the container. And the complexity, again, constant, because we're just able to very quickly, again, as shown in this diagram, just append to the end, right? We have a pointer to the end of our list that's maintained, or that would be a good implementation to have there, okay? Now, I'm going to go ahead and write a little helper function here. Let's just call it print list, and it should take in a standard list here, so we can actually print things out. So that'll be the idea here. And let's go ahead and get this on one line. Now, again, we don't want to forget some of our other C++ things. Let's make this const and pass it by reference just for performance here. And I'm just going to go ahead and, since we're going to do a lot of examples here, print some things out. I'll use a range-based for loop. Again, let's sort of build things up slowly here for our list. And let's go ahead and write out each of our elements here. And let's just go ahead and put the element and a comma. That's fine. And I'm going to sneak in an end line here for our cout here. And again, as I mentioned, just for good practice, since we're not changing any of these elements, let's make it const. And again, by reference here. Okay, so that's our basic example here. We'll go ahead and compile this. So here we are. And let's go ahead and see what this produces here. Okay, so this runs our program. Oh, let's actually call print list here. Print list, my list. Okay, So just a first use case here. And I'm just going to go ahead and, as I compile these, run these so you can see. So 1, 2, 3, 4. Again, each element being appended to the end here. Push back, very similar to if you've learned it in vector in the previous videos. So again, since this is a linked-based data structure, which again, if we bring up the whiteboard, the advantage is if I know the position where I want to insert by having some sort of iterator, then I should be able to insert in constant time here. So let's go ahead and take a look at it in the documentation and continue to add to our example. So let's go ahead and look at insert elements. So again, we can insert value before the specified position, okay? So there's a couple different overloads here that we have here, and let's go ahead and take a look at our complexity. Again, this is constant time here, okay? For situations 1 or 2 here, okay? Now for inserting a number of copies here, which we can do, let me show you with number 3 here. Where we're actually like creating a bunch of values. Let's see how that changes our complexity. Well, it's just linear in however many items we're adding. Okay, so just something to keep in mind. So again, if you're only adding one element, that's still constant. So performance-wise, pretty robust here. Okay, so let's go ahead and just look at some insertions here. I'll go ahead and keep modifying this list here. So with that said, let's go ahead and just do my list, and I want to insert. Now again, where am I inserting? I've got to choose the position. I'm going to use begin and my list, which is one way to get the iterator to the beginning of our list. And then let's just insert the value 0. So let's kind of write that out. So the iterator, or I should say the position in iterator to where we want to insert before, and then the value here, okay? In this case, 0, okay? So let's go ahead and print out our list every time that we modify it. And again, this is probably the right way to learn a little about these data structures and just, kind of keep modifying things here. All right, so here's our new example. We see that 0 has now been inserted here, and let's go ahead and just do a few more examples here. So let's go ahead and insert not at the beginning, but at the end. And let's go ahead and put 5, just so we get things in nice order. Because again, the end, what that's doing is returning the after the last element position. So effectively, it's returning something over here in our iterator. So if I want to insert before the end here, that puts me at the end of my list here. So that might be a little bit confusing, but let's just go ahead and try that out. And we could see that 5 is stuck at the end here. All right, so that's kind of nice. Now, again, since this is just an iterator where we are positioning things here, so let's go ahead and do another position or another little experiment here. Let's go ahead and just retrieve an iterator here. And you can do this, using begin here, or if it's not going to change, cbegin for constant. We'll go ahead and just do that here. And now let's go ahead and think about what if I wanted to insert something, say in the middle of the list here, okay, at this position. Okay, so if it's 5 elements, so before this element here, how would I do that? Well, we have to learn about a few other sort of standard template library things here, like I've introduced begin and end, for instance, but there are some other useful ones like next, for instance, which will sort of advance our iterator. So let's go ahead and say, let's write out this example. So now we will advance our iterator a specific number of steps. Okay, so I'm saying, okay, here's the position that I have here, and now I want to say iterator standard next, wherever our current iterator is, which is at the beginning, and then the size divided by 2. And then now let's go ahead and insert something into our list here, and I'm just going to pick a random value like 9. And let's just go ahead and run this. And we need to print out our list here. So there's my list. All right. And we see 0, 1, 2, 9, which was inserted, 3, 4, 5. Okay, so we figured out the size here, which at this time is 6 divided by 2. So we advance our iterator 3 spots, the beginning, 1, 2, 3. And then here is our next position here. Okay, so that's one way to work with things. So let's go ahead and just take another peek here at our documentation. And let's go ahead and find standard next, just because we haven't quite looked at this yet. And again, this is since C++11, takes in our iterator a number of elements to advance. Okay, so that's the idea here. We're just advancing through our iterator. Now there happens to be another nice tool, which I'll go ahead and search for here. Advance. So down here, and we can increment a given iterator by n elements here. Okay, so that's the idea. There's a slight difference between next and advance. Next, if you don't pass any arguments, that just implies the next thing, but you can move a number of positions. Advance here also doesn't return a value, whereas let's go back to next here, which does return an input iterator. So we'll have to get into iterators a little bit more, but just to show you again, let's just go ahead and use advance here as another example. Sometimes I'll sort of use this, I'll just sort of say, okay, let's set our iterator back to the beginning here. And then what I want to do is to use advance here. And advance is a little bit older. Next is a C++11 thing. That was another thing to catch here. My list. And again, we'll do the same thing. Size divided by 2. And then if we want, what we can actually do here is print out, middle is, and it should be that new value here. So I'm going to dereference our iterator. And then it should print out this value here. So let's go ahead and run this. Oops, looks like I made a little bit of an error here. And it looks like the iterator that I want to advance is the argument here. So I could put IT, I could put begin my list. Let's just put in begin my list here, because that's effectively what we want here. Oops, looks like one more mistake. And I'll have to actually look at what begin is here. Let me just pass in the iterator. There we are. Okay, so now we can actually see middle is 9. So we just advance this iterator to the middle position here. Again, that's another way to handle things. Okay, so anyways, we can see that this is working nicely. And we have advance. Again, I would sort of default into that if you, that's the sort of distance that you want to move, or again, if you're using an older C++, that's probably where I'd use advance. And again, if you don't need the return value because you literally are moving the iterator and don't need to retrieve it or set it to something else, you could just use advance, right? It is modifying here. Okay, so let's go ahead and look at a few other member functions here, getting back into list here. And now I want to actually look at some of the things that we can do with our list that we didn't look at with vector here. So let me go to list. Here we are. Standard list. All right. And we didn't look at reverse iterators, but I think that would be useful to actually look at. We could do the same thing with vectors, but here they are. So we can use rbegin or rend here, and that'll return a reverse iterator to the end. So let's just quickly look at, since we've got this thing sort of in sorted order here, how we can, reverse it. But I suppose it might be even more interesting or easier to see if we look at some of the operations here, things like sorting, for instance. Now, there is a standard sort that we can use, but list, since we're working with a link-based structure, we just need, our own sort here. So I'm just going to call mylist.sort here, and it's actually as simple as that here. And then we can print out our list, my list here, and then we should see the sorted version here. All right, so there it is here. And then there's a few other, special member functions to look at here. Again, I just want to go ahead and show you the complexity. Again, the order is preserved. You can pass in some sort of comparator if you want it to be sorted in ascending or descending order, or whatever order that you actually have, right? So you need to implement some sort of comparison here. Approximately n log n here, and it might vary depending on your implementation. But here are the other notes here. Again, this is different than just calling standard sort. This is a member function of standard list as indicated here. Okay, so let's go ahead and look at a few other interesting ones here. So once we've sorted our list, let's go ahead and we can also reverse the list. So that's another way to get it in sort of reversed order if you like, although you should probably just pass a comparator here to be a little bit more efficient, so you don't have to do that in 2 steps. And then there's some other neat things here, like we could do my list dot, and let's actually show these. Remove if is a nice one, so we can remove stuff, and this will be good practice here for folks who've been watching this series for your Lambda. I like remove if, right? It's a little bit safer to use. So the brackets again to, and we don't have a capture here. We're just setting up the condition here. So for some element, we'll just return, n, and I'm being kind of arbitrary here. Let's just return if n is less than 1 here. So it'll get rid of that 0 here. Okay, so that's our little remove if. All right, so we can see now that 0 is gone here. Okay, let's do that as another experiment here. So I'll print out our list, sorted and then reversed, filter out or remove elements less than 1 here so that everything is a positive integer in this case. Okay, so just a few other things that you can do there. So now let's just briefly, as another example, work with the reverse iterators. I'm just going to write this out as a for loop. So standard list of integers. And this time, typically we've just typed out iterator here if you want a forward iterator, but instead we could do reverse iterator, it. And that's going to equal, let me write it out on one line just so you can see it one time. Our list, but again, the reverse. So sort of the end of the list here is what we want here. We want to continue this iteration until we reach the end. So the reverse end. And then we could just move forward our iterator. But again, we're sort of moving backwards, if that's a useful way to think about it. Okay, so there we are. Let's just go ahead and print these out, reverse. And again, I'm going to dereference the element as I visit it here. And let's go ahead and give this a run. And you can see if we're iterating through this particular list in reverse order, that means we're doing 1 first, which is printed out here, 2, 3, and so on and so forth. Okay. Now, if you wanted, you could also use something like advance here, and advance your iterator in a backwards direction. That would also be fine if you're sort of starting from the reverse. So again, you could think about that if you want to combine advanced and next and some of these other tools for your iteration, or to jump 2 elements at a time and so on. Okay, so that's the idea. Just wanted to show you that since we hadn't previously looked at it. Let me go ahead and set up our screen here. There's still more to learn here. So let me move past the iterators. And now let's just look at a few other of these operations here. In particular, I want to look at merge and splice here. So let's go ahead and just open those up so we can get ready to look at them. Merge merges 2 sorted lists into 1. Okay, so let's go ahead and create another list that's sorted and then merge it in. And it gives some other specifics. The list should be sorted into ascending order. Okay, so let's see how our current list is. Well, it's reversed, so let's reverse it again to get it in ascending order. And then let's create another list here. So let's do another standard list of integers. Just going to call it my list 2. And again, let's just do something like 2, 4, 6, 8, 10. Again, we could use a list initializer to initialize our list. That'll set up things just fine here. So let's set up an experiment to merge to lists. Okay, so if you got some data that you want to merge, and then I want to merge into my list, list 2. Okay, and it's going to put in all the elements here. Okay, so let's go ahead and print out our list, my list, and let's see what it looks like here. Okay, let me go ahead and just create some space here just so you can see our experiment. Again, I'm doing the reverse to make sure that our list is in ascending order from all these little experiments that we've been doing. So go ahead and run it. And then we go ahead and see our list here. Okay, so if you're implementing some classic algorithm like, merge sort or something, you have that actual merge operation there. Might actually be a good experiment for you to implement merge sort using list, for instance, but you have merge to make it somewhat trivial. Okay, so there we are here. So that's merge. And again, just to show you, if I print out list 2 that I've merged, okay, and if I run this, again, you're going to see in our little experiment down here, nothing prints out. Okay, this is empty. So it is, in effect, moving all those elements over. Okay, if we look at this, so since C++11, right, it's using move semantics here. If we're using older C++, it's otherwise, it's not copying the elements. Again, let me make this a little bit bigger just so you can see here. But it is moving the elements, if you're on C++11. Okay, so we're transferring the ownership. Let's go ahead and look at splice now. So splice example. Okay, and let's go ahead and I'll go ahead and create another list. And we can sort of just think about splice here. If I open up the help page, again, transferring elements from one to another. Just do a quick eyeball test here of the different versions of splice versus merge here. Okay, if I look at merge here, I'm just taking another list and saying, hey, these two lists are sorted, and merge it. Sort of in the typical like merge sort. That's the sort of the way to think about it. So for splice, though, I get a little bit more power where I can figure out, the how many elements I want to transfer from one list to another from a given position, and then I can also specify a range. So let's look at this a few different times, and then I think we'll wrap up this lesson here. So what I'll do here is I'll just create another standard list of integers. Let's call it list 3. Again, I'll use a list initializer to quickly add these elements. Let's make them something like 15, 25, 35, some larger numbers here, just so we can see a little bit more easily what we're adding in here. And what I'm going to do now is let's just create a list 3 iterator here. And what I want to actually do with this, let's look at list 3. I want to position it at the beginning. And let's just advance it 2 spots here. So I want to splice in just a few of these elements here. Okay, so I'm going to advance this iterator here, list 3, 2 elements. Okay, so move 1, 2. Okay. And then let's go ahead and splice in this list here. So my list, splice is the call. Where do I want to position these things here? And let's give ourselves a little bit of help here. So this is always the position of the list that we want to add into. So let's add at the end of my list. Okay, let me break this up just so you can see it a little bit easier. And now let's go ahead and say, well, what's the list that we are splicing in here? That's list 3. Okay, so that's our next argument down here. And well, let's just see what happens if I do this overload here. Okay, and then I'll go ahead and print my list. Okay, and then we'll also go ahead and print list 3 here just to see what happens to it. Okay, well, if I just run this here and I say, well, from the end of my list here, which was all these things, I can in fact add 10, or rather 15, 25, 35. And oops, looks like I put 35 in twice. Let's make it distinct here. 45. And we can see that that works. And again, it's going to destroy or transfer ownership of our actual list 3 here. So again, you can see list 3 is just empty. Okay, that's the idea here. So anyway, here's our spliced lists. Okay. Okay, so let's go ahead and see, just to add a little bit more power here, this time using our iterator. Okay, so let's go ahead and I'll go ahead and let's just save this experiment here. But let's add a little bit more power here. Okay, and by more power, I mean just showing that we can add a range of elements here using the other overloads from Splice here. So this time what we're going to want to do here is figure out the range, meaning, you know, the first and the last elements here. Okay, so for that, I'm simply going to use our first element's going to be, well, wherever our list 3 iterator was, and the last element's just going to be the end of our list 3. Okay. So let's go ahead and give this a try here. Let me go ahead and center that so you can see. Again, here's our position where we want to start adding to. Here is the list that we are looking at adding, where we're going to start adding things. So wherever our iterator was, that should be somewhere here. And the range that we want to add for this particular list 3. So just the end. And let's go ahead and see what happens. Go ahead and run this, move it down a little bit. And again, we can see we have spliced in, or, you know, conveniently arranged the pointers that we've advanced to. So 1, 2. So now our iterator is here at 34 and 35. We've put that at the end of our list 3. That's what we said here. List 3 we've appended here. And we've, from our iterator to the very end, again, that's why it's taking those 2 elements. And then again, this splice operation is transferring our actual elements, or rearranging the pointers, so to speak, so that we have my list. And then my list 3 here, you'll see, is just left with 15 and 25. Okay, so it's kind of a nice operation. Again, if you're implementing sorting algorithms or working with data, that you can just kind of fit things together there nicely. All right, folks, so we've looked at a lot here. Let me go ahead and scroll through the code, give you a quick recap here of what we've done here with these experiments. So of course, we've been learning about list, a doubly linked list. Typically, as it's implemented, we have a little print function here. We can use things like pushback that we've learned about. We can insert into our list here different elements, and we get to choose the position using an iterator, so we can get fast insertion. We've looked at, again, inserting at different positions, advancing and playing around with iterators. We've even looked at removal of elements from our list here. With removal, some of the special member functions here, and then reverse iterators, which we hadn't looked at, and then these splice and merge operations. Again, splice being you want a little bit more granular control, and merge being taking sorted lists already and combining them quickly. All right, folks, so with that said, I hope you enjoyed this lesson. A bit of a monster lesson, these STL lessons are, but I want to give you a good overview of how things are working. If there's something that you'd like to see otherwise with list, feel free to let me know in the discussion. And otherwise, stay tuned. Make sure you're subscribed so you don't miss. I am going to talk about some of the other data structures, things like forward lists, which were added, and you'll understand the difference between those. All right, folks, as always, thank you for your time and attention.